Welcome, everyone. We're so excited to have you with us today for our Advanced Memory Tiering for Federal webinar. Today, we have several experts for you to talk through this topic, including Dave Morera from our product management and marketing team on the VCF side. You also have several experts on the back end who are going to be able to answer questions for you throughout. Please submit those into the Q&A panel. And we will have an opportunity for questions at the end. So thank you again. And Dave, I'll turn it over to you.
All right, thanks, Marisa. Hello, everyone, and happy to be able to make it. Today we have a really important topic, very timely, I would say, based on everything that is happening with memory out there. So it's no surprise that memory prices are increasing, and we do have a solution for that with VMware Cloud Foundation 9. It's a new feature, something breakthrough, just like vMotion was, HA, a couple of decades ago, VMware Advanced Memory Tiering with NVMe. So before we start, I do want to set some understanding of where on the stack I'll be speaking about. So as you know, VMware Cloud Foundation, it's made up of several key components, so such as compute, storage, networking, and those are those components like vSAN, NSX, and vSphere that you come to love and know for many, many years. So this feature is part of the core compute component. Say that fast 5 times. So that is one of the key features of the compute component that it makes up the entire VCF stack. And on top of that, we have some advanced services that makes the complete solution for the private cloud. So I want to start with a quick. I'm not going to spend too much time here on the why memory tiering, but I think it's important to understand why we started this project. And this may be a new feature for you, but we've been working on this for many, many years. Maybe 3 or 4 years or more. What we were seeing and customers were telling us is that, hey, when I go out and price out a server for virtualization, I know I want to pile as much CPU and memory as I can because I want to put as many VMs as I can. Right? That's the most economical approach. But it turns out that 80% of the price for a server came from memory alone. And that was 3-4 years ago. So that's how we started looking into this. How can we solve this problem for our customers? How can we help them reduce that pricing? Fast forward 3 years, and now we have this apocalypse that I call, where memory prices have skyrocketed. It's going out of control because of AI. Some memory makers are switching to HBM memory rather than server or enterprise memory. So we're seeing that increase in pricing demands. I'm hearing from customers, hey, I'm getting a quote that is only available for seven days, and then it expires, and I get a higher quote the next week. So there's a lot of problems that are happening, and this is what we're seeing is that it went from 80% for a bomb to now 96%, which is even worse. But again, that solution that we started working on 3 or 4 years ago still applies, and it helps our customers overcome this high memory increase in pricing over the years, right? So a quick overview of what's happening. I'm sure you know this, but we started many, many years ago, and now it's very timely. The time we came out with it, and now how we can adopt this on VCF 9. So what is exactly memory tiering? So memory tiering, when you look at it, here the green box is a host, ESX host. And on top of that, you have VMs, containers, or the applications running, right? Typically, they will run and look at DRAM as the only source of memory. But what we're doing now is breaking that memory allocation, or the way we present it through the host, in 2 tiers. DRAM will be your tier 0, and NVMe will be your tier 1. So we sort of aggregate those 2 tiers and present that memory as logical memory through the host to those VMs, the containers, anything that you're running on your host. We present them that as one. And right, so we're using memory tiering, NVMe as a memory tier. The VMs consume the logical memory, so they have no idea that, hey, on the background you have DRAM and NVMe. To them, it's just transparent. They just know, hey, I got 10 gigs of RAM of memory. That's great, and move on, right? But on the back end, we do a lot of the intelligence is what's happening on the ESX host, where we're typically looking at the pages and we're making decisions of where those memory pages live. And I would dive into this a little bit deeper in a second to explain how it works. But this is essentially what we're doing. We're taking a less expensive device, like an NVMe SSD, making that a second layer of memory, presenting both those layers as logical memory to VMs and containers. Now, if we dive a little bit deeper into the NVMe device, SSD, right? Right now in VCF 9.0, we do require that to be a local device, so connected locally to the host, not shared with anything else. We want that dedicated to just memory tiering, so no other partitions in there, logs or anything. We just want it to be dedicated for performance reasons. And we also have, one of the questions we get all the time is like, okay, great, but I know that this NVMe SSDs, they may have a shorter lifespan than DRAM, right? So we do have the ability to have a RAID, a hardware-based RAID solution with this. So you can have 2 devices per host. They will configure in RAID 1, and if one device fails, the other one can take over. So this covers the redundancy question that comes often as to, hey, what if that device dies? What happens? However, we do have some recommendations on the types of drives, and you can find them on the Broadcom configuration guide, compatibility guide, sorry. So we're looking at endurance, class D, performance, class F or G for these devices. We want them to be fast, and we want them to last. So typically what we've seen based on our testing and the usage, they should last you about 5 years if you follow our recommendations and have a good enough performance to sustain all the reads and writes. So what do you get out of it? So VMware memory tiering, again, is part of ESX, which is in turn part of VCF 9. So it is a VMware hypervisor native solution. There's no need for additional VMs or any appliances anywhere, but it's already part of ESX. So whether you have VCF, VBF, it's already included, no additional licensing. So if you have VCF 9 or above, you get this. But you also, again, we started with a lower TCO. How can we help our customers lower the total cost of ownership for their servers? And that's the solution for you, right? We find out that at 40% or even more in savings when it comes to lowering that total cost of ownership on memory alone. Now we also have the capability, and I'll talk about this more in a little bit, of having up to 4 times more memory. So if you have a host with 1 terabyte of memory, you can go up to 5 total terabytes of memory per host. And I say you could because it depends on the activeness of your workload. So there's some homework that you need to do there, but the capabilities are there to expand up to that much. We also noticed that there's a higher VM consolidation. So once you turn memory tiering on, you can throw twice as many VMs in there, make them bigger, make your host work for you, right? Get your money back that you pay for to have more VMs, and that with very little overhead. So that 2x VM consolidation comes with the lower TCO, but also comes with a better CPU efficiency. And I will show you this in a second. By that, I mean that you can use CPU resources more effectively, between a 20 and 30% better utilization for that. All right, so that is pretty much what it is at a 10,000 foot level. And then I want to get into how does it work, right? How is the magic behind the scenes that is giving you this solution? So when you look at a host, and this is what we're seeing quite often from customers, and even when I was a customer, I run into this quite a few times, where a lot of VMs were asking for more and more memory, especially SQL databases, things like that, and run into an issue where my memory was pretty much consumed 100%, 98%, 99%. That was one problem, right? Another problem was that all my hosts looked the same. I had both CPUs, for a dual socket board, both were allocated. All my DIMM slots were populated, so I could not just add more. I would have to switch them all out, which would be super expensive now. And my only solution would be to buy more servers. And especially now, it's kind of impossible if you get them. Even if you pay for them, it could take several months to get them, right? So the problem here is not only the scale problem here. We're also, not only are we memory bound, but the CPU is being starved for memory. We need CPU and memory need to be in constant communication. And in this case, memory being so full, CPU can't really be pushed anymore. So we're wasting resources here, even though that host is pretty much being utilized fully from a memory perspective. From a CPU perspective, we have plenty of room, right? And even though, most of the costs might be coming from memory, CPUs are not cheap either. So we're wasting not only those resources, but we're wasting the power and the cooling that those servers are taking. Now we have to buy more servers, and we kind of stuck between a rock and a hard place. And what do, right? We switch DIMMs and ended up having old generation CPUs. We get new servers, but now the new servers are not going to be compatible with the old servers. So I need to buy more servers to make a new cluster. So it kind of snowballs and creates a bigger problem here. And this is where we can come in, right? So if you dive and look into the CPU and memory allocation here, take a mental picture, and we transpose it to what exactly happens on the back end. So what we're doing is we are actually looking at the pages on the VM pages. Where exactly are they doing? Not only if they're being touched, but how often, in what pattern, and we're making decisions based on that. And we classify those pages into hot, warm, cold, or very cold. And that is one of the important steps in the algorithm that we're using here, is to classify those pages and then make decisions based on their state, their activeness, and also, how often they're being accessed. So right here, we just have CPU and DRAM. And let's say we just add NVMe SSD in this case, right? We have already classified the pages, and we know, hey, those cold pages are really not being used. We're wasting really expensive DRAM on pages that are just sitting there doing nothing, right? It makes no sense. So with NVMe, we're making that decision. Hey, I know we're not using those pages. Let's move them down to a way less expensive device that is NVMe, and to make room for those hot pages where it matters, which is DRAM. Now we have room. Now remember that I said at the beginning, we're taking these two tiers, tier 0, tier 1, and presenting that to the VMs as one. So even though we move pages around, the VMs still have access to those pages. So they move up and down as needed. If a VM needs a cold page, it will be promoted up to DRAM, be read from there to the VM, and vice versa, right? If it gets cold, then we move the page down to NVMe as needed. And that happens every few seconds as needed, and based on the classification. Now that we have moved those pages down to NVMe, you have noticed that DRAM has a lot more space, and we can actually, and this is where the VM consolidation comes in. Now we can push more, make those VMs bigger, add more VMs, and we can actually use that expensive DRAM into something that is actually working, which is those hot and warm pages. Once we do that, you can see that the CPU can also be increased, because now we can push it harder. More VMs are using both DRAM, CPU, and any of those pages that are not doing anything, those get moved down to the NVMe layer, tier 0. Right? So in essence, this is pretty much what happens from the background. Obviously, there's a lot more, but in essence, what we're trying to do here is that when there is pressure on DRAM, and I say that because people need to understand that we're not moving pages just because we can. We're moving pages when we have to make room for the hot pages. So we're trying to minimize any movement, but still make room for the hot pages and move the cold pages down to NVMe. All right, so you may be wondering, well, what happened to all the other stuff we had from memory, right? Back in the day, we learned about TPS, compression, ballooning, and if you're like me, I never experienced ballooning and swapping, you know it's not pretty. But these are different approaches as to how we handle memory, right? These are, I would say, towards the end, ballooning and swapping are more reactive, right? By the time you get to that point, something's happening with the memory allocation. But memory tiering actually is more a proactive approach, and it comes in right after TPS, after memory sharing. So all those solutions, all those approaches to memory handling are still there. We just added another layer towards the top and sort of push this ballooning and swapping down the road. They can still definitely happen. So if you overcommit memory at the top, even with memory tiering, you could still end up using the other reactive approaches, which are still there to kind of save those workloads. But again, memory tiering sort of jumps in there in the middle, but we retain everything else that you know about the memory handling from vSphere. All right, let's talk about some of the operations and configuration. So initially, we talked about having different tiers, tier 0, tier 1, right? Tier 0 is DRAM, and tier 1 is NVMe. So when we talk about ratios, we're talking about ratios between those two tiers. Initially, we came out with memory tiering back in vSphere 8.0U3 as tech preview. So you could still go out and play, test it out, call it the beta. And the ratios were 4:1, meaning that you had 4 parts DRAM, 1 part NVMe, which translates to about only 25% increase in memory. Now in VCF 9.0, that ratio, the default ratio, it's a 1:1 ratio, which gives you at least twice as much memory as you started with. So a host, as we can see in this example, host with 256 gigabytes of DRAM. Let's say you bought a device that is the same size, right? And you're gonna end up using all of it for NVMe. For memory tiering based on the ratio. You end up with half a terabyte of memory total for the VMs. Now, let's say you have the same example, but in this case, you decided to buy a bigger device, which is good in many cases. Number one, you can see here that even though we have a device that is twice as big, you're only using 256 gigs of memory, giving you the exact same total memory. Why is that? Well, because the ratio is still 1:1. So we go off the ratio and the DRAM size to give you how much we're going to use out of the NVMe drive. So when you configure that drive, it's going to configure a partition. In this case, a partition is going to be bigger, which gives you two things. Number one, there's some word leveling happening, so it could increase the life of the drive. But also, in this example, if you just go and for some reason your workloads are not as active as you thought they were, maybe they're very, very low activeness, 15% or so, you can say, you know what, we can really take advantage of this, and we can change that ratio to a 1:2. Now I went from 256 gigs of DRAM of memory, total memory, to almost a terabyte, 768 gigs. So we're increasing that. So that was, when you're thinking about sizing your drives, I would recommend at least having the same size as your DRAM or bigger. But in this case, we went bigger. It helped us because we decided to go higher eventually. If you stuck with the same size, and even though you decided to change the ratio later, it doesn't do much for you, right? You can't create extra space out of a drive. So if you decided to go a 1:2 ratio, but your drive is still the same size as DRAM, we're still going to use what we have, which is 256. So hopefully these examples help you understand, the relationship between the ratios, the DRAM size and the NVMe partition size, and how much you can use out of which, and what is the best approach when you're thinking about greenfield deployments or even brownfield deployments, right? Because this can be used for both, right? At the beginning, I talked about how do you scale out. So if you have a brownfield deployment, you can't buy new servers, you can definitely use that this solution. Or if you buy new servers, you can say, you know what, instead of buying 1 terabyte of DRAM, I'm just going to buy 512 DRAM, 512 NVMe's, NVMe drive, and go from there. So many different ways to approach this. All right, another question I get all the time is, well, how does it interact with everything else that we know about vSphere? And a lot of people don't, and understandably, they don't want to lose any of the capabilities or the features that we have, such as HA, DRS, vMotion, because those are, back in the day when I first used vMotion, I thought it was magic, right? It was life-changing. Seeing a VM move from one host, physical host, to another one was pretty cool, still pretty cool. But yeah, so memory tiering works with all the solutions that we have, all the features that we have in vSphere. And DRS understands, hey, I know we're using memory tiering. vMotion can move between different hosts, even if the other host, the destination host, does not have memory tiering enabled. And I say that just to highlight that we do. Sorry, I got ahead of myself. We do support having heterogeneous clusters. So meaning you can have within the cluster one host that is enabled for memory tiering, and you can have other hosts that are not enabled for memory tiering. So that helps you not only do some testing, but also helps you if maybe your active memory for a particular VM is too high for it to fit into memory tiering, or maybe it's a latency sensitive VM or a security specific VM, or you just don't want to involve it in memory tiering. You can remove that at the host level, or you can go VM by VM and disable that at the VM level, right? Yep, so we do support HA, DRS. Fast Suspend Resume is also part of it. And I talked about how we support RAID. RAID for the NVMe device in this case. All right, so I talked about this at the beginning a little bit, right? What happens when we have RAID and some failures. So within the RAID, obviously we're gonna fail to another device. When we have a single device, and this is a question I get all the time, what happens? So you do not have to start with 2 devices. You can start with one and add one later if you want. So if you do start with one single device, what happens here? So what's going to happen is that an HA event is going to be triggered on the VM. And I say VM because only the VM memory pages are moved to the NVMe device. So all the ESX host memory pages, there will always be on the DRAM level tier, and only the VMs are going to be on the NVMe device. Now, the failure or the HA event is not all at one time. It depends what the activities happen on the back end, meaning that if a VM is requesting a call page that lives on an NVMe device that is dead, right? Obviously, that VM would just trigger an HA event because it can't find that page. So similar to what happens when a DIMM is bad, right? So that could mean that if another VM is not really requesting a call page, it doesn't really know that the NVMe device is gone, it will keep going, and eventually it may just do an HA event, right? So it's not like it happens all at once. It could kind of start a few at a time, or it could potentially be all at once. So it all depends on what happens on the back end. All right, so from a configuration standpoint, in VCF9, so there's several ways to do this. And I'm showing you here the easiest way is to configure this through VMware configuration profiles, or VCP. You can see this as, or you can call it desired state configuration. Many people refer to it as many things, but It's a configuration profile. So if you're not familiar with it, it's sort of the replacement for host profiles, just at the cluster level, which it makes it really simple to configure, right? From the cluster level, you can go and tell it, hey, I want you to enable memory tiering, and it's going to do all the hard work for you. So it's going to enable that in all the hosts, unless you do a host override, and then do the automatic configuration. It's going to do the orchestration of moving VMs out of it, putting the host in maintenance mode, rebooting the host, moving on to the next host, etc. So it's going to orchestrate that work rather than you having to do this manually one by one. Now, I did mention earlier that you can have different hosts configured differently, right? One of them could be enable with VMware tuning, one disable. So you can either do that through here, through host overrides, or you can go host by host and do ESXCLI command to enable that and configure the NVMe partitions. Or you can do Power CLI. You can actually create a script, which I've done, to enable that on whatever host you want. So you have many different ways to do that, right? Obviously, if you have many hosts in a cluster, you want them all enabled, or a few exceptions, the easiest way would be to do configuration profiles, right? So again, super easy, and there's new things coming next version, so keep an eye out for that. And yes, I did not forget about security. So I know this audience may be very interested about security. So I do want to talk about that, right? We do offer encryption for NVMe for all those pages that get offloaded to NVMe devices. We have it at 2 different levels. So one of them, it's the host level encryption, and we have a VM level encryption. Now, this VM level encryption is not what you're thinking about. VM encryption is completely different, right? You can still use it with VM encryption, with vSAN encryption, with VTPM, all that stuff. You can still use all of that. This is just refers to the actual NVMe SSD. Any data that comes into the SSD device gets encrypted. So you can opt out and say, hey, if you do it at the host level, you can say any VMs on this host that are using memory tiering would get those pages encrypted right away. Or you can just go VM by VM, even if you want to test it out, or you just want a few VMs because the other ones are just test VMs or not important enough. You can just go to per VM level and say encrypt all the pages for this VM once it gets to the NVMe device, right? So as it's coming in, it's going to get encrypted. When it's gets called back up to DRAM, it gets decrypted when it goes to DRAM level. So what happens here is that we're going to create a random key, a 256-bit key. And when we say we, I mean the host. So the host itself is going to take on that job and say, okay, I know all the VMs in this host need to be encrypted. I'm going to create individual keys for each VM. I know I do not require a KMS or even a native key provider. So the host is going to handle the keys in this case, and is going to assign them as the VMs are power on, right? As when the VMs power off, those keys get deleted. So this is an AES XDS encryption mode, and we are using AES NI to offload some of that work to the CPU, which is consistent with our solutions like vSAN encryption or stuff. So to capture this, host generates an AES XDS 256-bit key. No need for KMS, no need for native key provider. The key is persistent only during the life of the VM. The only time we do copy that key is when we doing a fast suspend resume, right? Because in theory, we are copying that to the same host it lives in, right? So it's an in-place copy. That's the only time we copy the key. Otherwise, if we do a vMotion or there's an HA, once the VM goes into the destination host, it is the job of the destination host to create that new key and assign it to that VM, right? So there's a lot of keys going, again, based on the life of the VM initially. All right. Are there any questions? All right. So that's pretty much how the encryption works. Again, the host handles the key generation and regeneration when it gets to the other side. So I do want to do a quick recap. Where I went to that a little too fast, but I do want to leave you with this behind. I know you may have some questions, and a lot of this material here, it's going to answer those questions. And this is a resource hub page. I know sometimes it's hard to find information, so I made this page so that you guys can go out and find everything in one place. Some of the questions we get is about performance, so we have a performance section that we have a white paper that explains the overhead, which is minimum between maybe 5-10% overhead for memory tiering, depending on the workload, right? So you can dive into that a little more, but videos about that. And then I have a particular series on the left, which is pretty much explaining the sizing guide, how do you design it, things that I talked about here. How do I know my workloads work for memory tiering? What should I be looking at, right? So there's a lot of examples here. I even have I mentioned how to configure the partitions right through Power CLI. So I do include one of those samples in one of those blog posts here. They have a Power CLI script that you can test and run for how to configure the partitions for those NVMe devices on the cluster as well. So there's a lot of information. If you don't have an environment, we have a couple hands-on lab. We're working on a new one for the next release as well, so you guys can play with that as well as soon as we go GA. So yeah, definitely bookmark this, take a screenshot, scan the QR code. A lot of information and more comment for the next release. All right, so with that, I do want to recap again. VCF9, it is a game changer, right, for memory tiering. It is a big problem for our customers. A lot of, I've seen customers are really looking into this for many reasons. And obviously one of them is being the cost of DRAM, but also just the availability of not being able to get servers. I can't get servers. Not only they're expensive, but the time to get them would be 6 months. We need them now. We can't scale anymore. We're trapped, right? How do we go from here? So obviously we started with lower TCO, but now we're helping customers get past all these other issues as well. VM consolidation is another big one. Right? I talked about how, based on our testing with memory tiering level, you can have up to a 2x memory VM consolidation ratio. So now you can actually use a lot of those resources that you pay for. Even if your servers are 3 years old, 4 years old, you can't buy anymore right now, maybe for the next couple of years. So memory tiering comes into place, lowers your cost. You can scale your memory, be able to stay there, and now you can add even more VMs to your current environment. And lastly, being able to utilize those CPU resources more intelligently, right? Now, we're not going to be memory starved. CPU should be able to do a lot more now. You have more VMs utilizing CPUs, so you take advantage of that investment that you made on your hardware side. All right, I think that was pretty much it for me. Any outstanding questions, Marisa, Cindy?
I think all of the questions have been answered that have come in. If anyone has any others, please enter them in the Q&A chat. Sandeep, were there any that make sense to repeat out to the group or cover again?
So a few things. The link which was shared in the chat on the for the memory tiering, it lists the best practices, how customers can leverage the memory tiering, what ratio they can set. So the recommendations are there. It is not a hard bound recommendation, but the recommendation is there because we validated with that and we consider that as a best practice. So that is one thing. And in the upcoming release, we have a very detailed capability which is going to provide you with a what if analysis in VCF Ops console. That is something which you can leverage to understand and to plan accordingly. So, like, okay, if you enable memory tiering, what is the kind of CPU cores which you will unlock? What is the kind of savings you get? All of that details too. So yeah, it will even provide with the detailed guidance as well how you can walk through step by step.
Yeah, that's a good point. Make sure you do your homework if you're looking into deploying this, right? So we're looking at workloads. So we're not really when we talk about workloads, people usually think, hey, is the VDI good or is SQL good? It depends because it can behave differently, right? So when you're looking at workloads, we're looking at the active memory. And again, that's on the blog post, but we're looking at active memory to be under 50%. And active, it's not the same as consume. You could be consuming 80, 90%, maybe only 20% of that is active, really. And that's why we came out with this solution, because we found out, yeah, you're taking most of the DRAM, but guess what? Most of it is just sitting there doing nothing, right? So do your homework, and then that's how you can tell, hey, yeah, this workload qualifies, or yeah, my entire workload in all my clusters qualify, or maybe this one doesn't, because this one, the active memory is actually being used and is quite high. So I explained a lot more in detail what to do there. And how to categorize that, so you can use vCenter UI tools, and in future versions you can use VCF Ops even more to do this what if analysis. You can use all the tools like RB tools or Log Insight, not Log Insight, the tool, I forgot what its name. Login VSI, not that's either. Just like RB tools, right? So you want to look at the active memory and decide, hey, yeah, I'm within the 50% active memory or less compared to my total DRAM, to make those decisions, and always test before you go in production, obviously. But like Sandeep said, yeah, our ratios, and I see it in the QA, our default ratio is the 1-to-1, but yeah, there's capabilities to go higher. But we've done a ton of tests with the 1-to-1 ratio and push it really hard, through twice as many VMs to make sure everything's solid there from a performance standpoint, right? So there's a lot of things that come into play. Any other questions? I don't see one came in.
There is one new one, yeah, in the chat. Would you like to just answer that? Is there a tool in the platform that lets you know if you should convert the VM back to using DRAM only, and also how to better tune your ratios?
Not necessarily, not that I know. So I'm assuming if the VM would go over 50% or so active, right? But we're looking at the host or entire cluster per se, right? Because those ratios, the activeness could change on one VM, and could go up in one VM and then lower in another VM. So eventually, at the end, we're looking at the total DRAM versus the total active per host in Y, right? And making sure we're within the 50% or less, because we need room for the kernel pages, and we need room for failures, other things like that. So we're not right now, as far as I'm aware. We don't flag our VM and say, hey, this is way out of line. But again, we're looking at it from a higher level, from a cluster, from a host level perspective, what those ratios are. And by doing, there's a tool I've created, which is just a bunch of Power CLI scripts that it's actually on my latest blog post, which is a best practices blog post. That sort of looks into your cluster, looks at your VMs, active memory versus total DRAM, And it's going to say, oh, okay, your active memory is only 50%. You're good to go. You're good to enable memory tiering. So it's pretty basic sort of RV tools, but even more basic than that. That just looks at what we're talking about, right? How to qualify your workloads. So if you're interested, just go to blogs.vmware.com, and then the latest blog post I posted that Tuesday. What's today? Thursday? Yeah, a couple of days ago. Talking about best practices for memory tiering, which is pretty much a condensed version of all the other posts I have out there. And then you can explore even further if needed. Yeah, so hopefully that answers the question.
Fantastic. Well, if there are no other questions, I want to thank all of you for joining today, as well as Dave, Sandeep, and Rob for lending their expertise. We will be sending out this recording to all of you. And of course, I do encourage you to please take advantage of the blogs that Dave mentioned, as well as the Memory Tiering Resource Center. So thanks so much for joining. Everyone have a great day.
Thanks, everyone.